So yeah, I came all the way from Canada to talk about JavaScript. It's very fun. Woo! But hopefully all of you are CSS experts by now. We did hear some stuff about Sentry, but as Daniel mentioned, we're open source. So if you want to kind of help us out, PRs are welcome at any time. You can look through, see our front end. We're in and out. And help us out. And throughout the presentation, I'm going to actually try to give some examples from our Sentry React monorepo single-page application. If that sounds good. Cool. So yeah, I'm Abi. I'm a software engineer at Sentry. I work on the Web SDK team, mainly on the JavaScript SDK. Wrote a lot of like the React SDK, did some performance monitoring stuff, so I think I know a little bit about this. And today we're going to be taking a look at React, how things get slow, and hopefully trying to find some solutions to speed it up to both improve your lives and the lives of your users. So, brief agenda. One thing I always really like to do is actually not even dive deep into the code, but think about what I think should be the most important thing when you look at any web application, which is your users. So how is somebody using your web application? What type of web app are you using? I'm mainly going to stay in a browser context, but theoretically you can kind of, take some details here and there and be like, oh, you're a React and Electron app, or React Native, or I don't know, Ionic or something. These things should kind of translate, but mainly like a browser focus. Again, we have our open source repo. We're going to try to draw some examples and some anecdotes from that. And cool. So we're going to kind of split this into like two parts. The first part is we're just going to look at like an individual React component, how it works, try to get into its mind. Then look at how we can start measuring it, because this is very important, through both React DevTools and the browser DevTools. And then we're actually going to look at the React Profiling API, which is like bundled into React itself. Well, it's opt-in, but you should be turning it on if you're really interested. And then afterwards, we're going to take a step back and not just look at individual components, but pages in general, because no user actually really cares about the fact that like a dropdown is really fast. They care that a dropdown on the specific page is really fast, because that's what they see and use, the whole page and the whole experience that comes with it. So how do users use your web application? And what I mean by this is actually categorizing this. So typically we have like kind of two operations that we can mainly split our how users use your app into. There's the famous one. You open up your DevTools, you refresh the page, you record the profile, and you see, oh, the flamegraph from my page load. In most React apps, they're single-page applications. So we have the added complexity of client-side routing if you're using a routing library like React Router. So we also have like the route changes, the navigation that comes with just like browser state full routing. On the other side, we also do have React. We also do have user interactions, which sometimes is the most painful parts of using an app. If you ever experienced trying to like scroll through something on your phone on a site and it's so super slow and laggy, or you're trying to click a button and it's like you think it's debounced, but it's actually not. And there must be some event listener nonsense going on in the background. And not every application will have like 50% focus on page rendering and 50% focus on user interactions. Oftentimes you'll be focused on one more than the other. So you have to like figure that out, because that's where you decide to put your time and energy and effort into. So an example from Sentry, we have like an issue details page. This is what kind of shows off an error as it gets reported to Sentry. This is very much like, there's not much user interaction here. Maybe there's like some filters, some buttons to click, some scrolls, some event listeners here and there, but mostly people just want to load and see the error. Meanwhile, we have this great dashboards product, which you can visualize on aggregate scale, the data you sent to Sentry. And something like editing a dashboard is like completely different. You're in there for a while, you're experimenting, you're playing around, you're making new HTTP requests, and you're relying on kind of the draggables, the scrolls, and the clicks. Very user interaction driven. So with that in mind, I think that's enough context to actually start talking about React stuff. This is like a a React component. It's JSX, which is the JavaScript templating syntax. But this is really just like syntactic sugar. This gets compiled down into actual JavaScript function calls. But we can see we have a list item. I just pulled this from like a random component that we use in Sentry itself. It has a list. We render some children. We got some accessibility stuff, so bonus points there. And pretty much you can see that it's taking in some data and trying to render it. What's going on under the hood? Well, when we have the JSX, which again is just syntactic sugar over some JavaScript function calls. So when React is rendering, it just calls a bunch of these function calls and generates a virtual DOM, which we discussed a little bit before in the last presentation, which is essentially like a virtual data structure, some tree structure representation of your UI. Afterwards, then this is kind of usually skipped, so I'll come back to this for your first load. Let's say you just loaded a page for the first time. After React is like, okay, I got a virtual DOM representation, it'll try to take this and actually commit that update onto the actual DOM, or if you're in React Native, onto a mobile screen or whatever. And so this, manipulating things in memory, updating objects, sure, they can be expensive to a certain extent, but oftentimes it's the actual DOM layout I/O. You saw all of the CSS stuff, all of the kind of massive amount of steps it takes to even just render a pixel. And so this is definitely usually the bottleneck, but we shouldn't really ignore this totally. DOM layout is also important because React does more than just React does a lot of DOM I/O, but things like attaching event listeners is actually pretty cheap. You usually don't need to pay attention to it as much. So let's say you render a page, the user does some interaction or action, or another request comes in, so you have to kind of update the page with more data. Then we kind of do a re-render. So the backing data structure, the virtual DOM, will change again. It'll update in this tree structure, whatever it thinks needs to be changed. And then React will use this process called reconciliation right before the commit to essentially diff between what's on the page and what it thinks changed, and then try to do the minimum amount of work to put a new DOM representation and commit an update. So if it only thinks one element on a page changed, it will only try to change that one element. Oftentimes though, this is, we'll see. So what does that mean? Again, it's nice to optimize any one of these processes. You can spend all of your time optimizing reconciliation. But what we really like to do is try to minimize the DOM layout I/O. So minimize those commits to the DOM. So how can you tell? Well, if you're just sitting on your laptop and you just build something, open up the DevTools. So I have Chrome DevTools here. You can usually console.log. If it's a functional component, you just log out in the function body, see what's happening. Maybe it logs to the console a billion times. There's something a little wrong if your component keeps updating over and over. What's a little better though is to actually use the DevTools that are provided to you. There's the React DevTools, which helps you kind of parses the DOM tree for you and shows you the kind of React representation of it, or at least how React is thinking of it and what's being loaded onto the page. And then we have the browser DevTools, which helps you give kind of more of the high-level JavaScript stuff. So you can look at things like long tasks, you can kind of look at the CSS, or the images, or the network requests, and try to put it all together. So this is kind of a feature again, this is on a Sentry page. This is kind of one of the features of React DevTools. You can kind of visualize how things re-render. So as you load a page, it'll flash, and you can see that oh, this component seems to be re-rendering, and all of these too, and this is happening as the page is being loaded. Not very ideal, because you should think that this has pretty much finished loading, and so really it should only be this re-rendering, but step by step, we'll get there. Another thing that also kind of the React DevTools gives you is the profiler. So just like the browser DevTools profiler we got to see, you can do it for React components as well. And what happens actually is you can go commit by commit. So every time a commit happens, which again means that the DOM has been updated in some way, could be anything, you can see what React thinks, or what React kind of spent time on in terms of the render, when it was committed, and then there's some stuff about priority. In reality, I gave a very high-level explanation of the virtual DOM. There's much more things going on in there. A whole scheduler. They did a lot. But if you're curious, feel free to ask questions, or we can just chat about it afterwards. And then we have browser dev tools. I ran this on the Sentry site. It doesn't look that great, but I think we've already established this, which kind of sucks because that was like supposed to be my joke. But we can see that this also kind of helps put things into perspective because we can see we're registering routes. We can see that there's a bunch of tasks happening. And the long tasks API basically tells you, well, JavaScript is single-threaded. You want to make sure that a task doesn't take up too much of the single thread that you have. And it's like a heuristic that's just like 50 milliseconds. So anything above that, it's like, hey, you should maybe take a look at this. So past those dev tools, you can actually try to instrument your code yourself. So there's like a React Profiler API. And what you do is you have to, unfortunately, go into like your Webpack plugin or roll up and switch and point your React production bundle to your React profiling bundle. And then you get access to this. It adds like 2 kilobytes. But it's totally worth it if you have a huge application and you're looking to really dig into insights. And doing something like this is also really useful because you immediately go from just like, I have my laptop, I'm testing on my latest version of Chrome, 103 or something, and I have my dev tools, to I can just run this on everybody's machine, send the data somewhere, and then I have a perspective of how everybody's feeling and how everybody's doing. This is a really valuable insight, and we kind of talk about this in the performance world as like lab versus field data. But again, as I mentioned before, users are probably the thing that you need to pay attention to the most and care about. And so let's try, hopefully, to focus on the field data side of things. So we have the React Profiler API. Again, you track the timings you care about. So it'll tell you like the ID, tell you like the phase, and like the duration. There's some other stuff. This was actually removed, interactions in React 17. It was like a beta. But I just pulled this straight from the React docs. And we actually have tried using this at Sentry itself, just like to see what happens. We have like a performance monitoring product, as was shown. And so we actually have this onRender callback, which again the profiler will call with like a component and the phase and the duration. And we track that. We start like a span, which is just a thing of timing data. And we look to see, okay, how long was something, again, this could be mount or update. So how long was something mounting? How long was something updating? And again, open source, you can take a look. It's out there for anybody to read. We also even have the PR where we went back and forth and web shedding over this. So using the profile at Sentry, this is a screenshot from production Sentry. This is me. This is my account. Actually, it is my experience of loading this page, because I filtered by my email. And you can see here that we have kind of these React updates, so we can see that the entire app component, which is like the whole thing, is updating like multiple times, which is not the best look. We've tried to kind of like theorize about it. We can kind of see maybe like, we have like the network request, so maybe there was this initial update, and maybe one of these ones caused this, and definitely looks like this one caused this final update. And again, aggregating this data and pulling it out, suddenly you know that it's not just like you and your machine and your hardware, but kind of everybody feeling these same things, which is why I think the profiling API is super cool. So again, what are like some common problems to kind of look at? If you can see, you know, oh, that flamegraph looks bad. Oh, it looks like something like a lot of updates are happening. Event listeners are a big foot gun. You know, you're triggering constant updates on an event listener that's commonly called, and you're not like debouncing or trying to group them together. As we kind of showed off with a huge table, and we talked about virtualization, many components on a screen at the same time is also not fun, because then React has to do updates for all of these components. And the more components, just the more stuff that has to happen. Using React context, there's a ton of foot guns with it. For the interest of time, I can go into it for a very long time, but I'm not going to. There's also kind of this idea of expensive computations blocking the main thread. So again, single-threaded. You don't want to like spend 300 years on your JavaScript trying to parse some huge JSON file, for example. We want to make sure that the main thread is blocked as like this main thread block time is reduced as much as possible. And then we have, again, this concept of serial network requests, because you know that'll fundamentally affect things like page load. So even if it's not your React component's problem, your React component needs some data. And if it's waiting on one request and then another, suddenly you have like these 3 serial requests that it has to wait for all 3 to get to a completely finished updated state. And worst comes to worst, it might do like incremental updates at every single incoming HTTP request, which may not be the best user experience, and also isn't just necessarily the best behavior. So fixing the problematic component. Don't dive in and try to prematurely optimize. A big thing, especially with working on performance, is just like measure it always first. And if you take away anything from this whole night, it should be that you should always measure to see how big your problem is. Because otherwise, you're just guessing, and oh, maybe I made a win, but maybe you only made a win for 1% of people. Or maybe you only made a win for yourself, and all users still think it sucks. So please, measure first. But we talked about a variety of ways you can do this. Memoization is a super common one in the React land. So you see data coming in, and in order to kind of prevent components from re-rendering, because that's like the data being passed into the component, and that's how React kind of tells people to, React tells its components to re-render or to change how it renders. Throw into memoization. You can do a ton of bundle optimization. You don't have to necessarily be loading every single React component in. You can try lazy loading things, dynamically loading. This goes to both the JavaScript, but also like the other stuff, like the images. And then there's this idea of virtualization, which I'll talk about in a bit, but came up before. Oh no, my image disappeared. But if you really want to see the code, it's there. So I was actually just showing like a breadcrumb component. So we have react.memo. So this will help skip rendering if it thinks that it's being passed the same props. And it does like just a shallow equality comparison. If you want to do some more finely grained controls, because you know exactly the state of the data structure of your props coming in, you can control that all to yourself. Actually, this was like actually using a React memo call, so maybe it would have been nice to have it here. And again, remember not to overuse. Really measure something, and then try like fixing it. And if you can see the impact, looks good, because every time you memoize, there's also a cost. There's like some backing data that you have to store, and this adds up, especially if you have a ton of components. And so the general rule of thumb is like use it for bigger components that have their props changed not as much. Because the smaller ones with frequent updates, it's just going to invalidate the cache all the time, and then it's useless to have this wrapping memoization that never works. Oh! I didn't do this on purpose. But yes, we have like this memoization. We can see we have a ton of props in here that are coming in, but we're fairly confident that a breadcrumb isn't going to change that often. At least I hope so. Because again, it's loaded with the Sentry event coming in, which means that we can kind of say, okay, this should be memoized. It really only can be rendered once, and then committed once, and then stay committed. We can also kind of memoize computations. So there's this idea of expensive computations. You can't really see this with the React DevTools, but you can definitely see this in your browser. You can just browser DevTools by just looking at like the long tasks API, just looking at tasks in general and how long the JavaScript is running. And you can use React hooks. There's also the class components, class component lifecycle functions, or class methods. But I just put the hooks in here. And you can use these to kind of control, essentially, to make sure that you're only computing when you need to be, instead of every single time you're rendering a component. Which again, rendering isn't the most expensive part. It's usually like committing it to the DOM. But it's something that we should still care about. And then yeah, we can see we're using memo here for this kind of expensive computation or a flat map, and then we have a big sort, and assume it'll grow in complexity as the size of the amount of profile. And this is a pretty big array that's coming in. Also here, available for anybody to see. Lazy loading, also really great. We use this a ton in the Sentry code base to lazy load in routes, because each of our pages are kind of like React components, but in reality, you only need to kind of load one page, the one you're on. But we want to make sure that our navigations are snappy, so we lazy load the rest in. And so we have like this lazy load component that uses react.lazy, and this is like a dynamic import. This is also dependent on your bundler, so you need the bundler support for it, but if you're using like the latest version of Webpack or Rollup, should be fine. And then we're using kind of React suspense to set a fallback. But this is great for code splitting things because sometimes the impact isn't just like, oh, I'm running the JavaScript, but everything that has to happen before the JavaScript can even run, because it has to be, the request has to be made to bring the assets in, and then it has to be parsed and evaluated. And so the less of that happens, the faster your page loads. Then we have virtualization, which kind of goes to this idea of like rendering a ton of components. Very common with dropdowns, lists, tables, of like you really only need to render what can be seen by the user in the current viewport, because that's all they care about. So I would recommend just using a library for this, but you could definitely roll your own setup. We talked a little bit about in the last talk about viewport observers, so you can kind of use these to kind of estimate about like when do you actually render an element in. But just use a library. So again, that's like some detail on components. Let's try to think about, okay, stuff at the page level. Because sometimes you can only do so much thinking about components or like a set of components. And in reality, most React apps, this is true, are very complicated. They have many pages and many page states. This is the Sentry release page, which is actually a relatively simpler page. But there's still a lot going on. There's like a search bar, some drop-downs, lots of buttons to click. And seems like a lot of user interactions alongside a lot of data to initially load. And this is what like a user cares about, right? They care about like, what's happening on a page. And so this is why measuring the field is so important. You can do this. There's web vitals, which are a set of core metrics developed by the Chrome team that kind of capture on a high level the performance of your web application. It's important to remember, though, another thing I'd like you to take away, they're heuristics. Don't stick to them. They're not like, oh, my LCP is really bad. My application is bad also, because LCP is a heuristic and it could have picked the wrong largest element. Maybe the element your users don't care about at all. But still pretty good as kind of like a way to figure out how to align yourself. Then again, we have the React Profiler API. You can kind of, we send our stuff to Sentry, but you can send it wherever you want. And we have the browser emits a bunch of like performance data internally. In fact, this is how like Web Vitals works, because we just capture LCP and other data like that from the browser. And so here's an example I just grabbed from the MDN docs. Remember long tasks that we saw in the browser DevTools? You can actually capture all of these after a page is finished loading and observe them, and then say that, okay, process them in some way, send them to whatever data sync that you want. So no longer do you have to say, oh, of course I have to open up my browser DevTools. You can just use a performance observer and send all of this data to wherever you want, so you can start thinking about it. So yeah, really use field data to kind of figure out where to profile further. So all the kind of stuff I talked about at the beginning is very cool, but kind of pointless if you don't think it's actually going to be really going to be a problem or not. So use the field data to kind of point yourself in the right direction, see if it's affecting a lot of users, and then dig in with profiling because it's more granular, more accurate, and you can kind of really see the impact of your changes properly. So I kind of went through, this was, I guess, Daniel already did this. I didn't know it was going to happen. I should have deleted the slide, I guess. But I went through a bunch of APIs, like the performance observer, there's like other browser APIs that happen under the hood. If you just want all of this to happen automatically and the Web Vitals stuff too, you don't want to worry about like configuring everything, you can just use Sentry, which just all of this works out of the box. And I know this because I helped build this. And so we have performance monitoring. And again, I would really recommend you use Sentry to send this kind of data, to kind of think about how to dig deeper into your React performance. But it doesn't necessarily have to be the case. Start measuring, start putting that data somewhere, start making decisions on it, and just see where that goes. You can see we tracked Web Vitals. We can see there's a nice kind of, we track things like resources, network requests, paints, and of course the classic React mounting and React updating. And that's pretty much it.